Okay, here's your video lesson for 13.6. We're going to start with page 12 in your notes. The first thing we're just going to talk about are these different curves. This first curve is called a bimodal curve because you've got two spikes and the rest is kind of normal. So just label this one bimodal. And then this is the one that we're mostly going to talk about in the chapter when it goes, it's like a nice continuous up and then it comes back down. That's your normal curve. And that's the one that we're really going to focus on in this chapter. But there's just a couple more that they talk about in your book. The one that just goes straight across is called rectangular. When it goes kind of curves straight up and the letter, it kind of looks like a letter J. This is called J-shaped. And then here, where it starts up high and then comes back down to the right, that's called skewed to the right. I'll just write skewed right. And then this is the opposite, where it was spiked up on the left and it kind of comes down to the left. That's called skewed to the left. Okay, so the first thing they talk about is a normal distribution curve. And this is just part of the definition. Every normal distribution is defined for all real numbers. The first thing that you should take note of if it's normal is normal distribution is called a normal curve. Okay, but more importantly is a normal curve is bell-shaped. That means it goes up and comes back down. So normal curve is bell-shaped. And the other thing you should note is it's symmetric about the mean. Symmetric about the mean. Let me draw a picture. So it kind of goes up and back down. And right here in the middle at the peak, that's your mean, right in the middle. Okay, so that's what a normal curve looks like. Up and then down. And this one I actually wrote in for you because it's so important. So star number 3, the mean, median, and mode, if it's a normal distribution, are exactly the same number. Put in your notes, it's not approximately the same. It's exactly the same. That's different. It's exactly the same. So it's not pretty close, it's exactly the same. So that kind of comes up on your quiz. So not only is the mean right in the middle of a normal distribution, but the mean, median, and mode are all the same number, and they're right smack dab right here in the middle. Okay? We're going to use this Z table in a second, but when you are one standard deviation from the mean, about 68% of your population is within one standard deviation of the mean. And we're going to talk about that in a second. But if you look at this curve right here and you go one standard deviation to the left, one to the right, and you kind of look at this area in here, about 68% of your data falls right in here. Okay? Now if you go 2 standard deviations out, 95% of your data is within 2 standard deviations. So if I go 2 places out, all of a sudden that covers a lot of my data. Okay, so if you go 2 to the left, 2 to the right, most of your data, about 95% of it, is within 2 standard deviations of the mean. And we're going to talk about what that means in a second, okay? And then 99.7% of your data is 3 standard deviations away from the mean. So if I go 3 out, 3 to the right, 3 to the left, you just got about everybody. Okay, that's that whole curve. Okay, but I just thought that was interesting. So, all right, so to figure out these percents that I got right here, you can use this Z-score table, okay? and we're going to use that in just a second. But a z-score, here's the definition. It determines how far, and this is in terms of standard deviations, okay? A given value is from the mean. All right, so this is the one you're going to have to know to find a z-score. So star this one, okay? You take your value, whatever score you're talking about, you subtract the mean, hit equals first on your calculator, and then you're going to divide by whatever the standard deviation is. That's how you get your z-score, okay? And we're going to use that in just a second, okay? So here's an example. This would be like on the test, okay? Practice finding z-scores. Okay, so this, you have a normal distribution. You've got a mean of 80 and a standard deviation of 10. Find the z-score of 90. So this is your score, okay? This is, you want to find, this is the value that I give you, and you want to find the z-score. So take your value, which is 90, subtract the mean, which I just said was 80, and divide by the standard deviation, which I just said was 10. So 90 minus 80 is 10, 10 divided by 10 is 1. So your z-score is 1, okay? Now that's called the z-score, okay? So you can do that with all of these. These are just practice. So here if your z-score was 80, you would do 80 minus the mean, which is actually 80, divide by 10. So 80 minus 80 is 0. 0 divided by anything is 0. So here your z-score is 0, okay? If you had a value of 95, you do 95 minus the mean, divide by the standard deviation. So 15 divided by 10 is 1.5. So that's your z-score. And then the last one here, you got 64 minus the mean. Make sure the mean is always in the back, okay? You're going to get a negative number sometimes. And then divide by 10, you get a negative 1.6. So your z-score can be positive or negative. It doesn't matter. Okay? And let's just draw a picture of a normal curve again, just to summarize. It goes up, comes back down. Your mean, median, mode, all that's in the middle. So like in this situation, your mean was 80, so that's in the middle. You've got a standard deviation of 10. That means if you go one standard deviation out, you went 10 points, so that would be 90. If you go 10 to the left, that would be 70. Okay? So this is 1. Your standard deviation is 1. Your z-score is 1. The actual score was 90. Here, you're at negative 1. Your actual z-score was 70. Okay? So you have raw data. These are your actual scores. Okay, the 70, 80, 90. And then these down below are your z-scores that kind of correlate with that data. It'll all come together in a minute. This is all new, okay? But just remember in the middle, this is your mean, okay? You're at 0. Your z-score is 0, okay? All right, that's page 1.